Hey everyone, welcome to homework video 2.1. So today we looked at functions, and so we're going to go through our homework for today. All right, so let's start by looking at the relationship between a car, the amount of time a car is parked in hours. So we're looking at hours or time, and the cost of parking in dollars, so time and money, can be described with a function. Identify the independent variable and the dependent variable. All right, so remember the dependent variable is the one that depends on the changes that the independent variable makes. So in this case, the independent variable is going to be the hours, and the dependent variable will be the money in dollars, or the cost, because this is dependent upon the time spent. All right, so the money will change depending on how much time is spent with the car being parked. Describe the function with a sentence of the form blank is a function of blank. So we're going to say cost is a function of time, because the cost will change as a result of the time. That also means the time is the input and the money in dollars is the output. All right, suppose it costs $3 per hour to park with a maximum cost of $12. Sketch a possible graph of the function. Be sure to label the axes. All right, so we're going to have our hours be here. 1, 2, 3, 4, 5, 6, 7, 8. And then let's go ahead and look at our cost. Now, our max is 12, so I'm going to do this actually by let's see, 3, 4, 3, 6, 9, 12. Let's do it by 3. So 3, 6, 9, 12, since it's $3 per hour. So 0 hours is costing us nothing, right? 1 hour costs us $3. 2 hours cost us $6. 3 hours costs us $9. $4 costs us $12. But now the maximum cost is $12, which means after 4 hours, we're paying $12. All right. And so let's go ahead and make sure to label this, that this is cost in dollars, and this down here is hours. It says identify one point on the graph and explain its meaning in the situation. So let's, for example, say this one, and this is at 4 hours, it costs $12. All right, it says we did this. Identify one point, so I'll just draw a little arrow up there. That's what that is. All right, number 2, the prices of different burgers are shown on this sign. All right, so here's our burgers. Based on the information from the menu, is the price of a burger a function of the number of patties? So, is it a function of the number of patties? It's asking, is the price, meaning the price is an output, and the input being the patties, is it a function? So, we have 1 patty is $3.49, 2 patties is $4.09. Then we have another 2 patties, which is $5.45. Sorry, flip that, reverse it. There you go. $4.59. And Big Island is 4 patties, which is $6.79. So in this case, the input of patties is happening twice. So no, because the number of patties is repeated. In other words, there is not one singular x value for every y value. All right, the distance a person walks d in kilometers is a function of time. So d is our independent variable, time is our dependent, d, how far they walk, is our dependent variable, and time is our independent variable, the thing that's going to change how far we walk. All right, so let's select all true statements about the input variable of this function. So distance is the input. So what we are changing, or what is happening, if this is a function of time, then in that case, the distance is not the input. The time is, the time is the input, but this is time of day. All right, so they're trying to trick you a little bit here because the question isn't about the time of day. It's about the time in minutes since the walk began. So they start at a specific time and then we're counting how many minutes are passing and how far we're going as a result of that. So time of day is not the input. Distance is also not the input. Time since the person starts walking is the input. So that's going to be our input. T represents input. D does not represent input, that's distance. And the input is not measured in any particular unit. So the input in time is in minutes. So that is false because it is in minutes. And then the input is measured in hours. No. And for each input, there are sometimes 2 outputs. So if I were to look at the 5-minute mark, is it possible that the person has walked 6 kilometers and 7 kilometers? No, that's not possible because it's a function. And so at any given time, if I were to look at 3 seconds after I start walking, I'm only going to have one distance. It's not possible for me to have multiple distances in that case. All right, let's take a look at the next one. It costs $3 per hour to park in a parking lot with a maximum cost of $12. Explain why the amount of time a car parked is not a function of the parking cost. So the reason the amount of time the car is parked is not a function of the parking cost is because for multiple costs, or multiple, repetitions of $12. Oh, excuse me. We could have different hours. So for example, for $12, we could have 5 hours. For $12, we could have parked for 6 hours. So in this case, the time is not a function of the cost, but the cost is a function of the time. Number 5 says, imagine you drop a ball from 5 feet in the air. The ball bounces until it stops. What relationship could you describe in terms of the ball height and time? Graph a possible relationship. Okay. So let's say that I drop the ball at 5 feet. So let's do 1, 2, 3, 4, 5. And my starting height is going to be 5, right? So the relationship is over time, right? The ball is going to, let's say we do it in seconds because it doesn't give us a unit. Let's say we do it in 1, 2, 3, 4, 5, 6, 7, 8 seconds, right? So over time, the ball is going to, and this is not scientifically exact, okay, you all, but the ball is going to fall, bounce, come back up, bounce, right, and so forth and so on until it eventually peters off, all right? And so the relationship here is that the ball height is a function of time. Because at any given time, there's only one height that the ball could be. There are multiple heights that the ball could be, but at any specific time, so for example, after 1 second, right, there's only one height that the ball could be. At 4 seconds, there's only one height that the ball could be, okay? And so that height is a function of time. All right, that is it for your homework tonight. So super short. If you have any questions, feel free to message me, and happy Halloween. Your code word for today will be pumpkin.